Hello guys, welcome to another episode of the Algorithmic Illustrator. In this particular episode, we're going to go over the solution to Leetcode problem number 5, the longest palindromic substring. Okay, so the problem is given a string S, find the longest palindromic substring in S. Okay, so there are two keywords important. One is longest, we want to find the longest palindromic substring. And the second one is substring, not subsequent. So substring here means consecutive characters. Okay. And we want to find palindromic substring, okay, which means that the string is the same when seen forwards or backwards, it's the same. Okay, you may assume that the other information, the assumption they give you is that you may assume that the max length of S is 1000. Okay, so that's the thing that they give you, the assumption that they give you. Okay, so let's take a look at some examples here. Okay. So the first example here is BABAD, okay? BABAD, the palindromic, so here the palindromic substring would be, BAB, right? This first three letters here. So that would be the palindromic substring in this example here. In the second example, CBBD, the palindromic substring here would be BB, okay? So let's go ahead and take a look at how we can do that. How we can essentially find whether each one of them is palindromic substring. Okay, so there's two approaches. Not exactly two. I would say two optimal ones in which we're gonna use. I'm gonna explain one of the optimal ways here using dynamic programming. Okay, so before that, let's just think about the brute force solution. Okay, so brute force solution is pretty straightforward. We go ahead and evaluate all possible substrings and we just take the maximum one. Okay, that's pretty straightforward. How do we find all the substrings? Well, that's pretty straightforward. Substrings of length 1 would be all single characters, right? So B A D, right? All these would be single characters, right? So this would be of length 1, right? Of length 2, it would be BA, AB, BA, and AD, right? So this would be of length 2. Of length 3 in this case would be BAB, ABA, and BAD, right? This would be of length 3, right? And you could also go ahead and do length 4 and so on until you end up with the max of BAB. The entire string is a palindrome, right? This would be of length, in this case, 5, right? I'll just go ahead and do a length 4 also, just in case. Length 4 would be BABA and ABAD, okay? So the brute force solution is to go ahead and evaluate all these substrings and pick the maximum one, which in this case would be this one, BAB, okay? And notice that it can actually also be ABA, but you can probably return the first one. It doesn't matter, but in this case you would evaluate all possible substrings. So how we can do that? That's pretty straightforward. So what we can do is we can have a loop that essentially first it loops only for one character at a time, right? So for C in C from, like, this is pseudocode, from 0 to the length of the string, -1 obviously for indices. We first only do account for one character, right? And one character is always trivially a palindrome. So technically we don't need to even consider that case, but I just consider that case here just in case string is empty or something, right? So you can set the max length to 1 and have a loop that runs from all length 1, right? That evaluates all strings of length 1. Then we also need a loop that probably does consecutive, basically, pairs, okay? So for, C from, like 0 till the length, -2, for instance, right? And you want to, take I and I plus 1, compare the I and I plus 1 indices of each of the characters in a string, right? So for instance here, for the string like BA, BA, D, you would want to compare 0, 1, so that will be one substring. Then 1, 2, that will be another substring, and then 2, 3, another substring, and 3, 4, those are another substring. So this loop here runs to evaluate all length 2 substrings, okay? You can also do length 3 substrings, right? And so on, but from length 3, you can actually generalize it in the, actually you can generalize even these formulas, but I think it's easier in terms of readability to think of it this way, and then you can start optimizing if you want. So so for C from, so you compare C and C at I plus 1 essentially here, and you record the max length. If it's true, if they are the same, then max length equals 2, okay? Then C from 3 until the length of this entire string, right? So in this case, it would for BABAD, it would start it would if you take this example of length 3, it would evaluate this groups from length 3 all the way until length of 5, right? So the tricky part here is the mathematics, the arithmetic part, because what we have to do is we have to essentially get the hey guys, welcome back. Sorry, the my phone got shut down because of the storage capacity. It exceeded, so I had to delete some videos. But anyways, we're back, and what I was saying was the only tricky part is the arithmetic part right here, because what you need to figure out is basically how to get these groups, essentially how to match the indices to get these groups. Okay, so how do we do that, right? So like for instance, if we take this example here, BAB, so this is at index 0 and we're doing groups of 3, right? So how do we get this from the original string, right? So this group 3 will be, say, group 3, so k equals 3, right? Meaning that we're looking at groups of 3. So if we're at 0, the way we can get the end indices that is matching here, which in this case would be 2, right, would be I plus k minus 1, right? Because i's here in this case equal to 0, right? I equals I plus k minus 1 would give you the end index, right, of which you can do this. And this is generalized arithmetic formula that gives you any length substring, right? So let's take an example of groups of 4 here, right? In the original string you would start 0, 1, 2, 3, 4. If groups of 4, so k would be equal to 4. So you start I equals 0, and I plus 4 minus 1 is equal to 3, right? So you would get BABA, and I would move to 1, right? So then you would have I plus k minus 1 is 1 plus 4 minus 1 would be 1 till 4. So that's how we get groups essentially using this arithmetic formula, okay? All right, great. So what do we have to do here? So we have to evaluate the groups of 3 or more, and we have to basically use the Python slicing operator. So basically what that would look like is something like this. So for k from 3 till the length of the string, the total length of the string, what you would do is you would essentially, which is essentially the same thing I said over here, but essentially what you would do is you would figure out the start and end index, right? So for start, right, start from like 0 till the length of the string minus 1, right? Actually no, this would be length, since you're computing the index accordingly, this would be length of k, length minus k plus 1, okay? Because this index here, when you're evaluating, say if you're evaluating the groups of length 3, right? So the last index would be from 2, 3, 4. So it would be BAD, okay? So I would end there, okay? So and then you compute the end index, which is nothing but start plus k minus 1, okay? And you can just use the Python slicing. I mean, now it's just coding this, so it's an algorithm, but essentially what you can do is you can take a substring essentially from the original string. So you can do something like string from start to end, right? And check if it's palindrome. if it is palindrome. And if it is, then what you can do is you can update the max length, right? So that's the general idea here, right? So you are essentially brute forcing in generating all the possible substrings that can be formed. Length 1, like groups of 1, groups of 2, and then groups of like k, right? K, where k is greater than or equal to 3, right? And you're picking the max one. Okay, so this is brute force solution, and obviously, this is not desirable, right? Because if I recall correctly, this will, this will take something like n factorial, I think. I have to double check because you are evaluating every possible substring, right? In this case, yeah, so in this case, there are like, I guess 2 to the, actually not factorial, I think it's 2 to the n, right? Because you're evaluating of one character and 5 character and so forth. So the time complexity would be exponential, and the space complexity would be of 1, which would be good because you're not using any space here. But the time complexity here is not desirable, okay? So let's look at a better solution. And the better solution is very similar to the to the brute force solution. It's just optimizing the brute force solution. Okay, so when you're computing length 1, right, length 2, and then length 3 or more, essentially what you can do is you can use dynamic programming to store basically the results. Okay, so how do we do that? So let's take an example here, right? So let's take a simple example here, but it should be good enough for you to be able to extend it. So if you take CBBT, okay, so this is our string here. What we'll do is we'll construct a dynamic programming, we'll generate a DP matrix essentially, right, of n by n, where n is the length of the string. Okay, so what we'll do is something like this. Okay, so this table here is going to store the results of our sub problems, and we're going to reuse this every time. Okay, and the way to think about this is something like this, right? Essentially, if I want to check whether BBD is a palindrome, how do we do that? Okay, so one idea is that we can check whether the first and last characters are the same, and whatever's in the middle, we have already computed that. We don't have to check it again, essentially, right? We have already stored that in a table. I mean, this doesn't need to be 3 characters. Say it's says there's like 20 characters string, right? So there's this huge string, right? And we're comparing, say, like, we're taking groups of, say, 5, right? So we take the first character and the last character, right? First and the last, right? And whatever is in the middle, we've already stored the sub problems result for the particular problem. So in a sense, we're using the stored results here. Okay, so let's see how we do that. So first we construct n by n matrix here, and then what we do is we fill. So first we do characters of length 1, right? So that's pretty trivial. We fill all the diagonals with true because each single character is always going to be a palindrome. Okay, so C is going to be palindrome, B is single character is going to be palindrome, B is going to be palindrome, D is going to be palindrome. So we fill that with ones. Okay, then what we do is we check whether CB is a palindrome. Okay, so with this you can just go through and do consecutive characters and check, right? So you check I and I plus 1, right? Essentially I plus 1. So CB is not a palindrome, right? So you mark it as 0. BB is a palindrome, so you mark it as 1. BD is not a palindrome, so you mark it as 0. Okay, and this is again simple, maybe a for loop that checks I, that checks I and I plus 1. Okay, and lastly we are going to also so now we come to groups of 3 or more, right? So for that one, what we said was we're going to compare the first and the last characters and the result in between, which you have already computed. Okay, so how do we do that, right? So here, if we take the example of BBD, that's what we're looking at. Oh, sorry, CBB, that's what we're looking at here at this position. How do we determine that? Well, is C and B the same, right? So if we take CBB is C and B the same, right? They are not, right? And ideally, if they were the same, we would also look at the middle element, right? Which would be, in this case, for CBB, right? It would be this one, right? We would look at that middle element right there, okay? So we look at that, and it's not a palindrome, so we put it 0, okay? So BBD, okay? So BBD, okay? So we look at the first and last characters, that those are not palindromes, and we look at the middle one. So if we had something like BBB here, right? If these and these were also palindromes, we look at the middle one, which would correspond to the element here, right? And we would conclude that it's a 1 if it was BBB. But in this case, we would take the first and last characters. It failed. It's not; those are not the same, so we filled that with zeros. And essentially, the last character, which is the entire string, CBBD. So for CBBD, we look at the first and last character. They're not the same. But if they were the same, we would look at the middle one, which would correspond to this one, this element right here, right? Or actually, sorry, yeah, this would be this element here, but the earlier example where we had BBD would be this one. But yeah, you get the point, right? So we do that, and then the first and the last character are not the same, so mark it as 0. Okay, so now, I mean, while we're storing our results to the DP table, we take the max length and we store that, and we return that in the very end. Or actually, in this case, I guess the problem is asking for the string, substring. So we would, store the index of where it starts. Okay. So sorry about I guess here I also said max length equals 2. I mean, there's another problem where you have to compute the max, but that's trivial once you understand the concept. Okay. So that's pretty much it. So let's go ahead and try to, actually, let me show you my submission on Leetcode, and let's take a look at that. Okay, see you guys soon. Okay, bye. Hey guys, welcome. So this is the longest palindromic substring problem on Leetcode. And so this is a description, and here's my solution here. So unfortunately, one thing I want to mention about the solution is that algorithmically this is correct. But however, since I'm using Python in this case, the solution times out after a certain amount of time. So it exceeds the time limit, since Python is pretty slow compared to Java and C++, and especially for a long string where you have to store a list of lists using dynamic programming, this particular solution times out. But this is algorithmically valid solution. So what I'll be doing is I'll be showing you my solution here, but I'll be referencing another Java solution that another person has written, which is where was it? I'll show it to you. Basically with using Java. So that is also pretty similar in a way using DP, but just wanted to show my algorithm here for simplicity, which you can probably use in your interviews. So let's think about this. So I have my start index here, which basically records so when I'm computing the different palindromic substrings, and I'm storing that in the subproblems in my DP matrix, and when I'm storing the subproblems in my DP matrix, I can also store the start index. The reason why you want to do this is that in the very end, you want to return the longest palindromic substring. And if you do record the start index of where your optimal substring starts, and you record the max length, basically how long your palindromic substring is, then basically start index plus the max length will give you the end index for your given string to find the palindromic substring. Okay, so initially what I do is I create a DP matrix, which is initialized all with false, okay, or zeros, however you want to think about it. And then what I do is I also have a variable here called max length that basically keeps a track of the maximum length of the longest palindromic substring it has seen so far. So here in the first loop here, I go ahead and compute basically for all ones, like length of 1 for all strings of length 1, right? And after I do this particular computation here, so this is just going and filling in the diagonals with 1 essentially. And after I do that, I do the same thing for length of 2 basically. But in length of 2, all I have to do is compare the consecutive characters. So here I say if s at I is equal to s at I plus 1. Okay, and notice my for loop condition, it goes all the way until length of s minus 1. So it's not length s minus 1 included. So the reason why I'm doing that is that you don't want to go out of bounds when you do I plus 1. So you go ahead and compute all consecutive characters and check whether they're a palindrome, and you update your GP matrix. Okay, so this is for all strings of length 1. This is for all strings of length 2. Okay, now comes 3 or more, the case where you have you want to take groups of 3 or more and start basically finding your substrings. Okay, so this K here starts from 3 and goes until length of s plus 1. Now the reason why it's length of s plus 1 is that you want to check the entire substring as your last scenario, right? So in this example, for instance, BABAB, you want to compute groups of 3, which is BAB, ABA, and so forth, groups of 4, and groups of 5. So the groups of 5 is the entire string. So that's why you do length of s plus 1, since you also want to take the entire entire string as a substring, and you want to compute the palindrome that way. So in the inner loop here, all you are doing is you're dynamically adjusting the start and the end index for each substring. Okay, so here I have for I in range, it can also be referred to as start. I think start would be a better name here. For start, from 0 to length of length minus k plus 1. So this will be the start index, and the length of minus k plus 1 is that will be the range of the start index. And the end index, you compute that inside the loop here. So the end index is nothing but I plus k minus 1. Okay, as explained in the video earlier with the paper. Okay, so and then once you get the start and the end index, if you see that the characters at as the first and last index match, and whatever's in the middle, which you have stored in your DP matrix, is already a palindrome, then you can conclude that you're given the string that you're processing right now is also a palindromic substring. So what you want to do is you mark it as true, since it is a palindromic substring, the string that you're currently seeing, and you also compare the lengths. And if you do see that the K, the group, like groups of 3, groups of 4, is greater than the max length, right? You update the max length, and you have to also update the start index. So this is also important, because you have now seen a new string, which probably starts at a different index, and which might be of a greater length. So you update your max length and you update start index. So once you finish the processing this, you essentially have a DP matrix, a two-dimensional table essentially that stores all the results of your sub problems. Okay, and while you were computing the sub problems, you would have stored all your the start index as well as the max length. Okay, so all you literally have to do right now is pretty much return the substring from the main string, like right here, from start index till start index plus the max length, and then you are essentially done. Okay, pretty straightforward. This algorithm works actually. Like, I tested against some test cases here. So for example, CBBD, here the answer is BB and BB and so forth. I can also give another case like BABAB, right? BABAB, right? So let's test that also right here. Okay, and let me take a case where the entire string is itself basically a given. Oh, actually, this case is itself BABAB is entire case is the substring. BABAD is what I meant to test here. But in any case, this is also a valid scenario because this entire string is a substring. All right, entire string is itself a palindromic substring. Okay, so BABAD. Let's run the code here. And let's see what we get. It's processing. I don't know what's happening, but this should return BAB. Okay, so let's see what happened here. Okay, that got deleted a bit. Okay, so BAB, and the expected result BAB. Okay, and this algorithm works. It's just that when I submit solution, it times out. So let me show you another. So that's the time limit exceeded that I was showing you. Right, so let me show you the Java solution. And note, I mean, this is very similar to my code, but it's not actually my code. It was from one of the discussion forums here, so you can go check it out if because like all these comments come from discussions, so you can go ahead and check that out. Okay, so essentially it's the same exact idea. So what you do here is you create a two-dimensional DP matrix, and you have a single loop that starts from n-1, basically the entire groups, right? And also the J index is also updated, and you essentially do the same thing here. But there's also one small optimization that you can make, which is in a sense that if you have 3 characters string like ABA, then essentially what happens is that if you check the first and last characters, which is A and A, one character is itself a palindrome, so you can actually do an optimization here for checking 3 groups of 3, essentially 3-letter characters, 3-letter character words basically, by saying J minus I is less than 3. And here in the comments it also says that if the window is less than or equal to 3, just the n characters should match. Okay, so that's one optimization you can make. And if it's truly the case, this is similar to what I explained earlier with my earlier code in Python, where you go ahead and set the where it starts at, the start index, and you also record the max length, right? And in the very end, all you need to do is literally from the start index of where the substring starts till the start plus the max length will give you the actual palindromic substring. Okay, so yeah, I mean, so unfortunately in this scenario here, the Python code is valid, but like it timed out because Python is too slow in some occasions. So therefore, please refer to this code. Again, you can go to discussion forums here and check out the Java code. But yeah, I mean, the idea is similar. Idea is very similar. So that's pretty much it. Hope you guys enjoy it. I mean, mine got accepted here, but I can click again if you want. But here, like in submission, it got accepted. So go ahead and check this out, and I'll see you guys in the next episode. Take care. Have fun coding, guys. Okay, bye.